Okay, so we're going to do a few minutes on traumatic brain injuries just to try to explain how that affects the brain. Brain's like the most complicated organ in the body, so to help us out a little bit in this short time frame, we're going to use a metaphor. So the metaphor that we're going to use is an orchestra. An orchestra is a complex system to create something beautiful, so very similar to the brain, I think. There's individual musicians in the orchestra that come together in sections of like sounding instruments to produce a specific sound. And then there is a conductor that coordinates and times all of those specific sounds as a large group to create something amazing. And that's very similar to the brain. So the individual musicians in the brain are the neuron, which is the individual brain cells, and they send signals to other brain cells to kind of create these bundles of like functions, and they can even group up in larger groups to create regions of the brain, much like the musical sections of an orchestra. And they tend to be predictable in the areas of function. So the area of sight, sound, and even problem solving can be fairly predictable where those occur in the brain. And the conductor of the brain is the electrical field that is responsible for all of those signals that coordinate function, whether it is memory, thought, movement, emotions. All of those things are functions of the brain. And so our orchestra brain is similar in its complexity. The problem is when any one of those components gets interrupted, like in a brain injury, then the whole system may not work quite as smoothly as it should. So interruptions in the brain start by interrupting pathways. So this is my fancy neuron. I know, I'm an amazing artist. And neurons tend to individually not have a lot of power. That's why they group up to do more complex functioning. And when you have experiences in life and the time it takes to have those experiences over and over again, is you create these pathways where basically if a signal is sent from neuron to neuron to neuron, and then you do that again, and then you do that again, whether you're thinking that way or you're accessing a specific memory, all of those things create these pathways that your brain gets used to sending the signal that way. It's easier to send the signal in that specific pathway. And there's a lot more complex factors involved that help create your personality and your emotions. But you tend to react to stimulus in the same way. The pathway continues working that way. And so when it is interrupted, either by that injury that has happened either affects the neurons themselves or the electrical signal, there's an interruption in that pathway, then you start to see changes in that person. And depending on what pathway we're talking about, it might be a movement change, it might be a memory change, right? All of those functions of the brain, depending on where the injury has occurred, can be affected. And that injury can create permanent or temporary effects. So time is a really big factor. you can have damage to the brain at a single instant in time when that injury happens, or that injury can also continue having damage throughout time until, honestly, medical intervention kind of helps stop that. So the interruption in the pathway of the brain might just be like swelling or maybe even some bleeding, and that can continue to cause damage, or it can kind of be held still or stopped by certain medical interventions that they try to do. But either way, the pathway for at least some period of time is interrupted. And what we see happen, let's take memory for an example as a function that maybe has had some impact, because that's pretty common in a brain injury. So what happens is like this pathway for memory is that they can't remember, they can't access those memories along their pathway. And so they ask these same questions again, but don't remember the answer. And so they'll loop back to their questions again. So that's why a lot of concussion or more serious brain injuries, they tend to ask these same questions over and over again in this loop, because they can't access what just happened. They can't store those memories. And so they'll ask the same questions often in the same order because that pathway is well established. And so they ask those same questions but can't access the memory and therefore go back again. 15 seconds, 2 minutes, the loop kind of continues because they can't complete that pathway. There's an interruption in it. And what happens if that interruption is temporary is that maybe the swelling goes down, the pressure has been released through medical intervention at the hospital, and then some of that pathway is restored and they can start building memories again, or even accessing the memories that they couldn't before. But if that interruption is permanent, the neurons themselves have been damaged, the electrical signals can't travel because the proteins aren't there anymore that help that happen, then they have to recruit, the brain has to recruit new neurons to create a new pathway to establish the same functionality of the one that they lost. Now, in our metaphor, that would be like, oh, we've lost some of our musicians. We either need to get new ones and kind of help them establish themselves in the orchestra that we already have, and we'll see how it all fits together. The most extreme example would be if those neurons are not used in the same way. Your brain is recruiting neurons that haven't been used for that type of function before, and it's like asking, oh, we don't actually have anybody else to bring in, so we're just going to take a violin player and teach them the French horn, because we need to shift things around and have a balanced orchestra. That's going to take a really long time, and that violin player may not be the most amazing French horn player in the end. And so some traumatic brain injuries that do have those permanent interruptions, they go through cognitive rehab afterwards to try to retrain their brain. And it takes months to years to make that happen. And because they're learning things like perhaps movement, but perhaps like thought processes, where they're learning to read and write again, or kind of problem solve daily activities. And that can take a really long time, and it may never be perfect. Some people, those individual brains, whatever the injury is, they might come out looking fairly normal, functioning fairly normal. But there might be too much damage, or that individual person, they can't retrain their brain to do that function as well. And so they might have those deficits. So that's why traumatic brain injuries have such a wide range of spectrum as far as what happens afterwards. Some people recover fully, totally. And some people have these really apparent lasting deficits in the way that they function. And it really is just so dependent on the circumstances, the type of injury, which part of the brain is injured, and what function that part of the brain does, and then if the brain can kind of compensate afterwards. And that's very individual. So, again, that's just a brief overview of brain injuries and kind of how they interrupt brain function, but hopefully it's helpful.